Hello children, welcome back to the chemistry session. In previous session, we have seen what do an acids and bases have in common, and we had also seen dilution of an acid and base. In today's session, we are going to talk about strength of an acid and a base. Strength of an acid or a base. Let us start today's section, children. How can we find out or how can we measure strength of an acid and a base? In earlier videos, we have seen distinguish an acid and base with the help of indicators, and we have also seen dilution of an acid and a base. When acid and base dissolve in water, the concentrated acid changes to dilute acids. So, in today's session, we are going to talk about measuring the strength of an acid and a base. By universal indicator, we can find out the strength of an acid and a base. What do you mean by universal indicator? Universal indicator is a indicator which is made up of different indicator. It is a mixed indicator and which shows different color in different concentration of hydronium ions. I am repeating, children. Universal indicator is a mixed indicator and which shows different color in different concentrations of hydronium ion. By pH scale also we can measure strength of an acid and a base. What do you mean by pH scale? This pH scale was developed by Sorensen. pH scale developed by Sorensen. So Sorensen developed pH scale. What does pH scale represent? The pH scale has values from 0 to 14. This pH scale ranges from 0 to 14. 0 to 14, and the acid ranges from 0 to 6.9. So below 7 it is an acidic range or acid range, and after 7 it's a basic range. So acid ranges below 7, base ranges after 7 and less than 14. So pH scale is a scale. The value ranges on pH scale from 0 to 14, and from 0 to 7. From 0 to 7 it is an acid range, and when the value moves towards the 7, then its acidic character or strength of an acid decreases. That means when pH value is less, then acid strength is increases. That means on moving from 0 to 7, acid strength decreases. Acid strength decreases when it moves from 0 to 7. So towards 7, its acidic strength decreases, and from 7 to 14, its basic strength increases. Basic strength increases when it moves towards 14. Here 7 represents neutral range. So acidic medium or the range of acid on pH scale is 0 to 6.9. 0 to 6.9 is acidic medium, and 7 is neutral medium, and 7.1 from 7.1 to 14 is a basic medium. When value increases from 0 to 6.9, then pH value increases from 0 to 6.9, then acidic strength is decreases. For example, let us consider different acids, children. Like here acidic value is 0.9, here 1.0. So these are different acids, and the pH value is 0.9 and 1.0. So among them, which one is strong acid? The acid which has less pH value, this here is a strong acid. And basic strength is increased from 7.1 to 14. Suppose consider two different bases, like their pH value is 12.0 and 11.0. So among them, which one is strong base? Here 12.0 is strong base. It's a strong base, and 0.9 is a strong acid. So pH scale is a scale which value ranges from 0 to 14. In this scale, the acid ranges from 0 to 6.9 and base from 7.1 to 14. And neutral substances, the range of neutral substance is 7.0. So this is pH scale. It was invented by Sorensen. By using pH scale also, we can measure the strength of an acid and base. Because in pH scale, the word P indicates potent. Here, potent means power of hydrogen ion. Power of H plus ion, hydrogen ion in the given solution. When we talk about pH values of some liquids, like pH value of gastric juice. pH value of gastric juice is around 0.9 to 1.0. And pH value of curd. pH value of curd is around 4.5 to 5. When we compare these two, when we compare the liquids like gastric juice and curd, here gastric juice pH, the pH value of gastric juice is around 0.9, and curd is around 4.5 to 5.0. Or lemon juice, its pH value is around 6.5. Among them, which one is strong acid? Gastric juice is strong acid, and these two are weak acids, because as pH value increases, strength of an acid decreases. That's why pH value is inversely proportional to acidic strength. pH value is inversely proportional to acidic strength. Okay, and this pH value is directly proportional to basic strength, because as pH value of the base increases and its basicity increases. That's why pH value is directly proportional to basic strength. This is because on moving from 7.1 to 14, its basic strength increases, because the base ranges from 7.1 to 14. That is the reason why here 12.0 is strong base, 11.1 is weak base. For example, concentrated sodium hydroxide. Its pH value is 14.0. And magnesium hydroxide, its pH value is 12.0. So So among them, which one is strong base? Concentrated sodium hydroxide is a strong base, and magnesium hydroxide is a weak base. Because when I compare them, here concentrated sodium hydroxide is more pH value. More pH value means more basic strength. Okay, so by using universal indicator, what do you mean by universal indicator? It is a mixed indicator which is made up of different indicators and which shows different colors in different concentration of hydrogen ions. It's called universal indicator. And pH scale, it was invented by Sorensen, and pH scale is a scale which is ranges from 0 to 14. And in it, acid ranges from 0 to 6.9, base from 7.1 to 14, and neutral medium is 7.0. So towards 7, acid strength decreases, and towards 14, basic strength increases. That means on moving to the right side, on moving towards right side, acidic strength decreases, basic strength increases. So the acid which has a lower pH value, which has more acidic strength. That's why gastric juice has more acidic strength because its pH value is 0.9, which is less than that of curd and lemon juice pH value. And in case of bases, pH value is directly proportional to basic strength. And here concentrated sodium hydroxide pH value is 14 and magnesium hydroxide pH value is 12. That's why here concentrated sodium hydroxide is a strong base because its pH value is more, and magnesium hydroxide is a weak base because its pH value is less than that of concentrated sodium hydroxide. Remember children, in case of acids, on moving towards right hand side, acid strength decreases. In case of basic medium, on moving towards right hand side, basic strength is increases. So this is the way we can find out strength of an acid and base. How can we define a strong acid and a weak acid? Strong acid or weak acid can be defined as the acids which easily furnish hydronium ions in aqueous solution. Those acids are called strong acids, children. I am repeating, the acids which easily furnish hydronium ions in aqueous solution. They are called strong acids. For example, HCl. It is an example of strong acid because in aqueous solution, HCl produces its respective ions, H3O plus ion and Cl minus ion, and H2SO4. In aqueous solution, in water, H2SO4 produces ions, that is 2H3O plus ion, H3O plus ions and HSO4 minus ions. So these acids easily produce hydronium ions in aqueous solution. So these are called strong acids. The strong acids can be defined as the acids which easily furnish hydronium ions in aqueous solution. They are called strong acids. How can we define weak acids? Weak acids can be defined as the acids which do not easily produce hydronium ions in aqueous solution. For example, acetic acid. Formula of acetic acid CH3COOH. And in aqueous solution, in water, this acetic acid is ionized to acetate ion CH3COO minus and H plus ion. Again, it is these acetate ion and H plus ions combine together to give acetic acid. That means ionization completely doesn't take place in case of acetic acid. That's why it is indicated by reversible error. Reversible error indicates both forward reaction and backward reaction takes place. That's why it is an example of weak acid. Acetic acid is an example of weak acid. And HCOOH. HCOOH is a formic acid. In aqueous medium or in water, this formic acid is ionized to format ion HCOO minus H plus ion. So here formic acid is ionized to format ion HCOO minus ion and H plus ion. Again these ions combine together to form formic acid. So these are reversible reactions. Reversible reaction means both forward and backward reaction takes place. So these are called weak acids. So formic acid, HCOOH, acetic acid, CH3COOH are called weak acids because complete ionization do not take place in this case. So they are called as weak acids. Strong acids means the acids which completely produce ions in aqueous solution are called strong acids, and weak acids means the acids which do not completely produce ions in aqueous solution. So they are called weak acids. And similarly, strong base. For example, sodium hydroxide. In aqueous solution, the sodium hydroxide is ionized to sodium ion and hydroxide ion. And potassium hydroxide. In aqueous solution, potassium hydroxide is ionized to potassium ion and hydroxide ion. In aqueous solution, the substances like sodium hydroxide and potassium hydroxide completely ionize to their respective ions and produce more number of hydroxide ions in aqueous solution. So they are called strong bases. Coming to calcium hydroxide and magnesium hydroxide. In aqueous solution, calcium hydroxide is ionized to calcium ion and hydroxide ion. So complete ionization doesn't take place in case of calcium hydroxide. And ammonium hydroxide, NH4OH. In aqueous solution, ammonium hydroxide is ionized to NH4 plus ammonium ion and OH minus ion. In this case, reversible reaction, both forward reaction and backward reaction takes place. So they do not completely ionize in aqueous solution. So calcium hydroxide and ammonium hydroxide are called weak bases. So based on the number of ions produced in aqueous solution, acids are classified into strong acids and weak acids. Bases are classified into strong bases and weak bases. Here, hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid are example of strong acids, and acetic acid, formic acid. So most of the organic acids are weak acids. And coming to bases, sodium hydroxide, potassium hydroxide, lithium hydroxide, cesium hydroxide are example of strong bases, and calcium hydroxide, magnesium hydroxide, and ammonium hydroxide are example of weak bases. Now let us see application of pH in everyday life. So how does pH affects our day-to-day life activities? Let us see pH in daily life schedule. Importance of pH schedule. First one, pH in digestive system. pH in digestive system. We know that the food which we eat in the form of carbohydrates, proteins, fats and vitamins. The food get digested with the help of digestive juice. What is the pH value of digestive juice? The pH value of digestive juice is around pH value of digestive juice is around 0.9 to 1.0, which is nothing but hydrochloric acid. Digestive juice is nothing but hydrochloric acid. Its pH value is less. If the pH value is less, it is a strong acid. So, during digestion process, the stomach releases digestive juice. Its pH value around 0.9 to 1.0. So, if we have food, the food get decomposed with the help of digestive juice and we get energy during the process of digestion. Suppose if you don't take food on time, then these acids are secreted in digestive system. Then we may suffer from indigestion. Indigestion means excess acids. When excess acids are present in the digestive system is also called as acidity. What do you mean by acidity? Acidity means excess acids or more number of acids secreted in the digestive system. I am repeating, children. Acidity can be defined as excess acids or more number of acids secreted in digestive system is called acidity. If the person is suffering from acidity, we have to suggest antacid, children. Antacid is the remedy of acidity. What do you mean by antacid? Antacid means it's a mild base. Antacid is a mild base. Mild base means it's a weak base. This is because if we don't take food on time, there is acids already secreted in the digestive system. These acids damages intestine. That's called ulcers or cancer. So to get rid of this pain, to get rid of this pain and irritation, we have to consume antacid tablets. You might have heard the word Gelucin. These are example of antacids. Antacids are nothing but mild bases. When the person is suffering from acidity, he has to consume antacid tablet. Then this antacid tablet has basic nature. This base neutralizes excess acids in digestive system. So this is the way we can get rid of acidity problem. Here we are talking about digestive system, pH value, digestive system. If we don't have required amount of pH, or if our stomach is not having required pH value or narrow pH value, the pH values get decreases, then more number of acids are present in the digestive system. It causes acidity or indigestion. It creates indigestion problem. To get rid of indigestion or acidity, we have to consume antacids. Antacids are mild bases to get rid of digestion. That's why humans digestive system should maintain required pH value. So this is pH value plays crucial role in digestion of food. And second one, tooth decay. Tooth decay. What do you mean by tooth decay? So we eat and we chew many food items during the day. Suppose if we don't wash our mouth properly, then some food particles are present in the gaps of the teeth, and this creates bacteria and microorganisms in the mouth. When the microorganisms or bacteria are present in the mouth, this mouth decreases pH value of the mouth. When the pH value of the mouth is lower than 5.5, when the pH value of the mouth is lower than 5.5, it causes tooth decay because these microorganisms or bacteria releases acids. These acids corrode tooth enamel. What do you mean by tooth enamel? Because teeth is covered by strong part of the body, that is called tooth enamel. These are hardest substance. Tooth enamel is the hardest substance in the body. But this tooth enamel is made of calcium phosphate. Chemical formula of calcium phosphate is CH3PO4. It is the hardest substance in the body. But this tooth enamel is corroded by acids secreted by microorganisms or bacteria in the mouth. So this causes tooth decay. By using toothpaste, we can get rid of tooth decay because toothpaste is a mild base. Toothpaste is a base which is made up of mild base. It's a big base. So when we brush regularly, this remove unwanted bacteria and microorganisms in the mouth. So this is the way we can prevent tooth decay. That is why we have to brush twice in a day. This is because when pH value of the mouth is lower than 5.5, it causes tooth decay. By brushing our teeth twice in a day, we can get rid of tooth decay. So in this case also, pH is important. pH concept is plays a crucial role in case of tooth decay also. And next one, pH of the soil. So how can we test pH value of the soil? We have to take sample of soil from the different areas of the yield, and we should add little amount of water to that. Then when we stir the solution, when we keep aside for some time, we get liquid. When you separate the liquid from the mixture, then the liquid is tested by indicators like methyl orange and phenolphthalein. We can test the nature of the soil. If the soil has acidic nature, if the solution turns to red color when we add methyl orange indicator, then the soil has acidic nature. If the soil has acidic nature, then we have to supply basic fertilizer. Or if the soil has basic nature, then we have to supply acidic fertilizer. Because soil must have narrow pH value. It should be neither acidic nor basic. The soil pH should be the soil pH should be moderate. If it is not, we don't get required amount of yield, and the pH value of the soil is not appropriate. That's why here concept of pH is applicable in case of pH of the soil. And acid rains. We know that acid rains damages buildings, and acid rains damages yield of the crops also, and animals and living beings, because acid rains means when the pH value of the rainwater is lower than 5.5, then it creates acid rains. This acid rains decreases the yield of the crops, and it also decreases the lifetime of the ancient buildings. And best example, Taj Mahal. The beauty of the Taj Mahal is getting decreased due to the acid rains, because the acid rains contain acids. The acids present in the acid rain which react with the marble of the Taj Mahal, and the reaction has taken place between the marble and acid. It forms other compound. That is why the Taj Mahal is getting changes into yellow in color. So these are the importance of the pH in daily life. So this is today's section, children. In today's session, we have seen strength of an acid or a base and importance of pH in daily life. So this is today's session. I hope you understand today's session, children. We'll meet in next session. Thank you.